works in a field like quality control, it's helpful, our absolute value inequalities are helpful to figure out whether different parts meet requirements. So stick with me on this problem and you can kind of see what people in, like I said, jobs like quality control do. It says to pass inspection, a computer part must measure from 0.0049 to 0.0051 millimeters. Now, that's not much room for error there. First of all, millimeters pretty small, and we're talking about 49 10,000ths to 51 10,000ths. That's really, really, really a fine margin of error. So the directions here say write an absolute value inequality. So let me show you how you would write an absolute value inequality. You start by writing a compound inequality. We know it must measure from 0.0049 to 0.0051. Okay, so when you write your inequality, we have our 0.0049 has to be less than or equal to whatever variable you want to use. I'll just use x, I guess, which is less than or equal to 0.00. Okay, so that's our compound inequality, but that's not an absolute value inequality. So here's what you do. I want to find the halfway point. Okay, I know it has to be in this range, but what's exactly halfway? So if you look at these two, if you were to take your bigger measurement, 0.0051, and subtract your smaller measurement, you would get 0.00, this actually would be 0.2. So 2 10,000ths of a millimeter is the halfway point. I'm sorry, that's not the halfway point. That's the distance between them. So if you divided that by 2, 0.0002 divided by 2, you would get 0.0001. So, and I probably am putting more work into this than you would. The halfway point between these two, we'll just add 0.0049 and you get 0.005 or 50. Okay, so the halfway point between these two is 5,000ths or 50 10,000ths. Okay, so which you probably can see from these numbers, but if not, find the difference, divide it by 2, okay, and then add it onto your smaller value. All right, why is this important? Okay, so if you have your computer piece here, okay, I want to know how far off in either direction I can be off. So what you do is you find the halfway point and you see how far away is that from the middle. All right, stick with me. So what we did, we wrote our original compound inequality. We found our halfway point. Here's what you do. Subtract your halfway point off from everything. So we go x minus 0.005. And again, if you want to raise 50s, that's fine. But whatever you do to one side of your inequality, you got to do all over. So I'm going to take this right here and I'm going to subtract 0.005. And on this side too, I'm going to subtract 0.005. Where does that leave me? If you go 0.0049 minus 0.005, you get a negative 0.0001. And over here, if you go 0.0051 minus 0.0050, you get a positive 0.0001. Not too much error there. But here's what this does. Let me write it maybe, hopefully, a little neater for you. little bit neater. Notice what this does. We say it's going to be in between negative 0.0001 or negative 1/10,000, or it has to be less than 0.0001, negative, positive. That's like saying the absolute value of this. The absolute, once you get to this part, then you can just say the absolute value of x minus 0.005 has to be less than or equal to, remember less than because it's in between, 0.0001. Okay, so when you think back to when we were first learning to solve absolute value inequalities, remember if it's less than, it lies between two things. Okay, and the absolute value is always positive. So let me go through this again. Write your compound inequality, find your middle, and subtract it from all three parts. When you do that, you're going to see how much you can be off on either side of your halfway point. Okay, so here's our halfway point. I can be off by 0.0001 in either direction. When we get there, then we can write our absolute value. You take whatever's in the middle here and the absolute value of it. Why though? Why would you want to do that? Why can't you just say, hey, is it between our two original numbers? Well, the reason for it is now that we have an equation, we're able to much easier see whether a part passes inspection, like in part B here. A part measures 0.00495 millimeters. Will it pass inspection? You know what? Maybe you can look at this and see whether it'll lie within this range or not. But sometimes it's hard to see when we're talking about very, very, very small numbers. But what we can do is we can take this number and we can plug it in for x. And what we ask ourselves is if I take the absolute value of 0.00495 and I subtract the halfway point, 0.005, is the absolute value of that less than or equal to our margin of error here? So when you subtract 0.00495 minus 0.005, you get negative 0.0005. Now, is the absolute value of that less than or equal to our margin of error here? And I apologize that I'm writing so sloppy. There we go. Is this number the absolute value? So the positive of this is that less than or equal to 0.0001? Yes. So will this part pass inspection? Yes, it will. Okay, but by having our absolute value inequality, we're able to plug numbers in and see if they pass inspection. Say, all right, here's the number I've got. At the halfway point, give or take this much, and it'll pass the inspection. Okay? So one more time to reiterate. Write your compound inequality. Find the halfway point and subtract it from each part. When you do that, then you can write your absolute value. Take your x expression here, and these two numbers should be a negative and a positive, which allows you to set up the absolute value. Again, when you're in quality control or something like that, having an absolute value inequality helps you figure out whether parts or other things are going to pass inspection.